So thanks for coming in, everyone. I'll be talking about diffusion models. In case you haven't heard this term before, you might have seen images on the internet of people generating images using text prompts. Those are diffusion models. So it seemed like a pretty cool topic. And I'll spend some time trying to really understand what happens under the hood. And I thought I'd just talk about my journey trying some of these models out and how you could get started yourself. So let's set the context first. I'm going to make a statement. So in 2024, image generation AI is so accurate that it's almost scary what it can do. So let's imagine for a second that you come up with a prompt like this. A photo taken at a data community meetup, specifically data in Sydney, enthusiastic tech folk, a great host, community of learning, beaches and beer. Sounds really familiar, doesn't it? So imagine putting a prompt like this into an image generation model and then getting something that looks like that. It even got those steps right. So how cool is that kind of technology? But just a bit of a disclaimer, that's not AI generated. That's just a photo from the last meetup. But here's what it actually can do. So took a similar prompt, threw it in, and it came up with this image. So you see some items that sort of make sense, like it should be that a tech meetup. And I think it's pretty cool what this tech does. So hopefully by the end of this talk, you'll understand how we can generate photos like this one. So I'll just set the agenda first so you know what to expect. First, I'll go with a quick intro to talk about myself, my experience working with these models, and talk a little bit about the industry because GenAI is so new. There's so many buzzwords, there's marketing hype. So I'm going to talk about what's real and what isn't. I'll be talking about Midjourney, which is one of the models that I've used a lot, and I think it's a good starting point for most people. And I'll be talking about Stable Diffusion, which has a very different approach towards how they bring models to end users. Sorry?
Before I take a photo of each slide, will this be posted up?
Yes, I'll drop a link at the end if you do want to get these slides and look at it yourself. Feel free to take snapshots of the ones that interest you, but I'll send the slide across as well. I'll also be talking about the kind of creative controls that you have with these models. So you have ComfyUI, which is my preferred UI for working with these models, and how we use some techniques like control nets and LoRa. So if you work with Stable Diffusion models, I'll just quickly recap how it can be best used. And I'll also tell you how you can get started so that you can go home today and start generating images yourself. And we have a few minutes at the end for a Q&A. So with that, I'll start with a quick introduction about myself. So I'm Harish. I'm a lead data consultant at Mantel Group, and we're an Australian consulting company that works with cloud, digital, and data projects. I used to take photos in the past, so I used to have a Canon DSLR, and I used to edit photos in Lightroom, so that's how my journey with image editing and the sort of creative side of images really started to develop. And in 2015, data science became a pretty big thing. Harvard Business Review said that the data scientist was the sexiest job of the 21st century, and I said, maybe I need to go back to uni, study how some of this stuff works. So I got a master's degree understanding how machine learning models work, and I use a language called R, which is very different from what most people use today. I got a job in data working as a data scientist. I worked at a media company where I was using YOLO. It's a machine learning model called You Only Look Once. It's a fast scanning method to find what objects are in pictures. So we grab a thumbnail, run it through the model, and the model will tell us, here's a dog, here's a person, here's a car. And then we'd feed that into other models like our recommendation engine to recommend new movies and content for viewers. Eventually, I moved to data consulting. I found that the data space was moving so quickly that people didn't know what were the relevant skills to pick up, what were the best tools to use, and I enjoyed working with clients who use Snowflake, Airflow, Kafka, and primarily AWS to build any of these solutions. So if you want to chat about that, happy to chat after the event. And at the moment, I like shiny things, so I'm helping build solution accelerators and demos for large language models like ChatGPT and the other open source models, and looking at GenAI use cases so that people can actually use this technology themselves. Now, setting the context, there are a few topics that I don't intend on talking about today. Happy to chat over networking, but just in the interest of time, I won't be talking about the ethical, legal, and commercial impact of Gen AI models. That feels like a bit of a can of worms. I won't be doing any benchmarks on specific model versions. I did start making a benchmark, but then over the Christmas break, everyone released new models and my benchmarks were out of date, so it's kind of hard to keep up with that. I won't be going too deep into the math behind the underlying architecture, so if you're looking for information about UNets, ResNets, variable autoencoders, and latent spaces, we just lightly touch upon it, but I would imagine most people in the room are pretty new to GenAI. Maybe a quick show of hands if anyone really wants to listen to some of that. Yeah, okay. I didn't think so, but let's chat over beers if you want to talk about that. We're not going to talk about the optimal parameter selection for these models. It does vary on a case-by-case basis, so we do have the slides, but it's cut for time, and if we do have time, I might touch upon it. There's a lot of models that are specifically designed to do face swap, so you can put in your picture and a celebrity and then swap it across. I won't be talking about those models because I think that's a bit more of a niche use case. We'll be talking a lot more about the underlying technology and how it works today. And the other new trend is video models, so you could just give it a prompt and generate a quick video. I haven't got into it yet, but it uses a lot of the same underlying technology, so I imagine it should be transferable. So let me start with this picture. Maybe a quick show of hands. How many people know why this picture was in the news a year ago? Okay, a couple of folks. So in case you haven't heard, this was an image that was entered into an art competition and it won first place. It was generated by an American artist using something called Midjourney, which is what I'll be showing today. And there was a lot of negative press and publicity about whether you were allowed to use AI to participate in art competitions. And when this happened, I believe it was September of 2022. So that's when I started wondering, how do these models actually work? And I started my journey kind of exploring the space back then. And I discovered latent diffusion models. And that sounds like a mouthful. There's a lot of complex math involved in what these models do. But I'll try and explain it like I would to a 5-year-old. So effectively, it's a machine learning model that's trained to denoise an image or remove noise from an image. And the way it works is you'd start with an image. In this case, you've got a picture of a cat, and then progressively add noise. So you'd randomly add noise in and have a set of pictures until it's pure noise. And that's called the forward process, and that's easy to do. Then you'd use a machine learning process to do the reverse. So you give it the last picture at the end and say, how do I get to picture number 3? And then you get the model to learn how to do that. And then progressively, it gets better and better until you have a completely new image. Now, if you're starting from random noise, how do you really guide the model to generate what you want? That's where step 2 comes in, and that's based on the transformer architecture. So the transformer is like the hottest thing in the data science industry today. So the T in ChatGPT, the last T, stands for transformer. And it's a kind of a very popular framework, very popular model that can really work with large data sets and learn different concepts. I know that text sounds a little messy there. It says it encodes text into latent space and you wonder what that means, but effectively what it does is this. You would take a piece of text, like a corgi playing a flamethrower trumpet, and then you give it a picture, the one on the top, and then train the model to really understand that these are two related concepts. So what we're looking at here is OpenAI's CLIP model, which is really good at creating that association between the text and the image. So when a new prompt comes in, it's able to decode it and then generate the image that's required. Won't go too deep into that today, but that's effectively what the underlying technology is. And there's a lot of popular models like OpenAI's DALL-E 3, there's Midjourney, there's Stability AI Stable Diffusion, which is what we're talking about today, but the landscape is constantly changing. I honestly don't think that my slides are going to be relevant in 3 months because something newer, shinier, better is going to come up and it's going to be so much easier to do all of this. So I'll start with Midjourney and tell you why it's a good starting point for most people who want to build some of these models. Midjourney is really good at generating images, and it can generate a wide range of images, starting from illustrations like this one. You could put a prompt saying an illustration of a children's book with a large flower, a small young girl, and it would generate an image like that in 30 seconds to a minute max. And that's a beautiful picture. It would have taken a human being hours to generate something like this, but models like Midjourney make it really easy to get something like that. On the other end of the spectrum, it also is really good at photorealistic images. So As a photographer, I look at this picture and I can see that the person's face is in sharp focus, the background is out of focus, and his hands are out of focus, which is what you'd expect when you're using a DSLR and shooting with a very specific focal length. Now remember, that isn't a real picture. That's completely generated from scratch. So the model has these understandings of how focus works and how it should generate something that looks realistic, and that's pretty powerful.
So that guy doesn't exist?
That guy doesn't exist. He came from random noise. So if we can do both those things, imagine all the possibilities that exist in between if you could combine some of these concepts and do interesting things. And this is just image generation, which is the simplest way to use Midjourney. You can also do a few other things like in-painting. So here's a prompt, and these pictures are from the Midjourney documentation, so you'll see the same pictures on their website. So here's a prompt of a meadow trail lithograph. So you've got a pretty picture here, but it looks pretty bland. Like it feels like it's missing a subject. If you went in and threw in another prompt or tried the same prompt again, because of the randomness of these models, you'd get a completely different picture. So in-painting lets you vary a very specific region and throw a new prompt. So let's highlight that area and say we want something in there. And we'll add a prompt saying we want a hot air balloon. You run the diffusion model and it'll put it right there. It knows which pixels to vary and it makes sure that the style sort of blends in with the rest of the picture. So you might get shadows in the right places, the colors. Everything looks like that hot air balloon's been there all along. You can't tell that it was something that came in later. Let's try one more time. So let's try a castle in the meadow. Same thing again. So you can see how you can just keep selecting the regions that you want to vary, try different prompts, and the model is intelligent enough to figure out, okay, here's the art style that I should be using. These are the colors, and it sort of does all of that. You're not specifying any of these things. You're spending zero design effort, and that's really where the power of some of these models come. Now, this is just in painting, where we varied something within the canvas. What if we wanted to vary something outside the canvas? That's out painting. So we start with a picture like this. And let's say you want to post it to Instagram, which requires a square image. The typical workflow would be you sort of crop out the sides and you have fewer pixels left in the final result. But with Midjourney, you've got an option called Make Square, and it would expand the canvas out and then fill in the top and the bottom. And it looks like all those pixels were there all along, and that's pretty powerful. For reference, that's the image that we started with. It understands the context of what are the pixels that are surrounding this image and what needs to go in to sort of suit the theme. So it's not just cropping. What if we could do some more things? What if we could do something like zooming out on an image? That's not something you can do with traditional photo editing tools, but with Midjourney you can. So it sort of adds a lot more information. The original image that we fed it was just that small section in there. So you can zoom out, you can pan, you can do a lot of these things, and it's really easy to do. So if you want to get started with Midjourney, it's as easy as signing up for a Midjourney account. You need to install Discord. They do have a web app coming in any day now, but at the moment it uses Discord as a UI, which is a chat app similar to Slack or Teams. And you go to the bot and you just start a chat and say /imagine and the prompt you want. So in this case, I'll put vibrant California poppies. And it gives you a few options. So it says, here's 4 small thumbnails, which it generates in a few seconds. And you have a few options. You can pick one of the images and then either upscale them, which is what the U's indicate, and it just creates a high resolution detailed image. You can choose to vary them, where you know that the image is close to what you want, but not exactly what you want. And you can choose to just try a fresh batch. So throw it out, get something else, keep trying until you find what you need. And after a few attempts, I got that picture, and that's it. That's the whole image generation process. You don't need to know what diffusion models are under the hood. Just go to the app, type something in, picture in a minute. It's that easy. So here's 8 reasons why I love using Midjourney. It is super easy to get started. Anyone can go in, type in a prompt, you get an image, done. You don't need any specialized hardware. You don't need a GPU. You don't need cloud resources. It's a fully hosted solution. So you could run it off your phone if you wanted to. You don't need to have any prior knowledge of diffusion models, so you could skip my whole talk today, go to Midjourney and still be able to do all of this. But please do stick around. There's some interesting things in it. And you get pretty good results with minimal prompt engineering. So we know with a lot of these models, you need to understand how to prompt the model to get what you want. But I think the Midjourney model has been really tuned well. So we see with some of the new ChatGPT models, like they're really tuned to give you a good experience. I think the team at Midjourney have done a good job at getting what you want out of the box. You also have high consistency. Some models that I've tried have issues where the faces are deformed. You get a few too many fingers in the hand sometimes. And I've seen pictures where there have been chairs in the middle of tables. So you get weird results. Midjourney has a few, but it's fewer than most models. So I think that's why you have a higher success rate. If you're a power user, you can also play around with settings like seeds, the styles, and the chaos of the generation. So you can control some elements of the generation. You can do in-painting and out-painting really easy, as I've just shown. And you've got something unique to Midjourney, which is the describe command, which is a reverse image generation. So you throw in a picture, which is like a photo of us at this event, and then it'll throw you back a prompt so that you can feed the prompt back in and keep generating more and more and more. So Midjourney is the only model that I've seen that does that quite well with high accuracy. So definitely give that a try if you get a chance to play with it. Now, as much as I love Midjourney, there's 7 things that I don't like about it. Starting with the fact that it's a paid option. There is no, they used to have a free tier, but it doesn't exist anymore. So subscriptions start at $10 a month, and you get about 3.3 hours of GPU generation time. So it is limited. The only UI at this point is Discord, which isn't necessarily the best way to generate images. You don't have an API. The website is going to be getting that soon, but I've been waiting for a while for that feature to be released. And the images are public. So anything that you generate is going to be publicly available on the Discord server. So you're going to have to pay for a $60 tier if you want to generate images in stealth mode. So if you do have privacy concerns, this may not be the choice for you. And it doesn't support external networks like control nets or LoRa's, which are 2 of the things that make other diffusion models quite nice to use. It also has limited ability to influence the model parameters. So I've generated some of these images for some of the slides that I've used at work. And my managers come back to me saying, hey, can you like make that person's hand bend down or look, can you have that person look the other way? Midjourney doesn't give you any settings. It is very much like a closed box where you just throw in a prompt, it gives you a picture. You can't really guide the process as much. You also can't generate images of yourself, any objects that you have. So if you are planning on creating product photos of images of products that you own, that doesn't work with Midjourney because the model hasn't seen your data. It hasn't been trained on any of your data sets. And finally, it's a proprietary model. So the moment you stop paying, you can't generate any more images. You still own the images you have generated, but a lot of people don't really like this concept of being locked out of a service that you used once. So in the world of tech and software development, finding ways around proprietary models or proprietary tools has led to nice things like open source development. So I like to think the world would be a better place if we all had open source. And thankfully, with image generation models, there is, and that's what Stable Diffusion is. So Stable Diffusion is effectively an open source model created by this company called Stability.ai. So they donated the compute power needed to train this model, and this was a donation made to the ComfyUI group in Munich, and they used all these resources to train a massive model that could generate these images. Now, if you want to run Stable Diffusion yourself, you can just go to the website. You're going to get the model that's been trained on hundreds of thousands of hours on massive cloud infrastructure for free. You just go click download, you get the entire model. You don't have to pay for anything. If you want to train your own variant of the model, you can go to GitHub and you get all the source code. So it's completely free and open source. You can start off at where the team at Stability AI have stopped and sort of fine-tune the model with your images, add on to it. And I think that's a very different model from what Midjourney uses, which is proprietary and closed. But it does have its pros and cons. With Stable Diffusion, one of the challenges is it's not just one model. Midjourney is one service today where you get images. Stable Diffusion has a whole family of models, and they sort of fall into 4 broad categories. So as of Jan 2024, here's the 4 popular models that I've seen. And this is an image that I've generated with the first one. So Stable Diffusion 1.5 came out in October of 2022. And this is sort of the first model that really went mainstream, where people started to understand, hey, that's what a diffusion model is. Here's how I can generate these images. And that's where a lot of people really understood how to use these things. And it's popular in the community even today. So I know October 2022 isn't that far back in the past, but this is sort of a legacy older model. So things have gotten a lot better since then. We have plenty of community-driven model checkpoints, which means people have downloaded these models that came out in October, trained it to do specific art styles. So you have styles that have been trained on famous artworks by different painters, different movies, different anime characters. So you've got a lot of community support. So if you want to download add-ons, extensions, the majority of the products that you find on the market are based on Stable Diffusion 1.5. And why do we not talk a lot about SD 1.5? Well, unfortunately, it received a lot of backlash when it was released because it was trained on harmful images, which were not appropriate for a lot of situations. And they also trained it on unauthorized IP. So they found that it was trained on licensed images, which they shouldn't have used for the training process. And if you want to know how they found out that these images were used in the training process, some people try to generate sports photography, and it added the Getty Images logo as a watermark. So that's an easy way to get caught. So that's where Stable Diffusion 1.5 kind of started off, went popular. I think it's where things started to go mainstream, but had its fair shares of controversy. So a month later, they released Stable Diffusion 2.0. So this was in response to the controversy where they used a reduced filter data set, so there were fewer images. The licensings were gone, but a lot of people said that the image quality wasn't as good as 1.5, so the adoption by the community was pretty bad. A lot of people chose to stay on 1.5 in spite of all the risks and concerns, and I think today it's slowly fading away from usage. So if you're starting, I wouldn't recommend this one. The next take is Stable Diffusion XL, extra large. So this came out in 2023 because they found that no one was using Stable Diffusion 2. And to make the model, the images generated by the model a lot better, they use a much larger model with 3.5 billion parameters. So it's 3 times bigger than the last one. And it also split the model into 2 parts. You have a base model, which gets you 90% of the way there. And then there's sort of a refiner model, which is really good at sort of filling in the fine details into the image. And they found that training 2 separate models gave you much better results. And I've seen a lot of development use Stable Diffusion XL as the base. So if you're starting today, this is the one that you want to start with. And then the most recent addition to the family is Stable XL Turbo. So this came out just before the holidays in November. And it's a distilled model that's been distilled from the extra large one. And its claim to fame is it can generate 10 to 100 images per second. So if you go online to see the demo of this one, I think they were trying different images of cats, and they were getting hundreds of pictures in a second, and they were fairly good. So it's still in research preview at this point, so you don't see a lot of adoption in the community, but it's probably going to become the one that's going to be the next big model that you're going to see in the market. Now, that's the different models that you have. Let's look at how you'd be able to run these models yourself, and this is assuming that you're going to be hosting it somewhere. So you're going to need at least a consumer-grade GPU. So this is like those GPUs you use for gaming or video editing. So you're going to need higher RAM, CPU, and video RAM requirements to run these models. So they do work with some of the Apple M2 and M3 laptops, but I've heard that you want a dedicated GPU for best performance, or you just wait a lot longer. You have to go download the model from Hugging Face. So Hugging Face is like GitHub, but for different models. These models are large. They're typically 2 to 6 gigabytes in size. So just download the model, start running it yourself. And you're going to have to pick a way to interface with the model. So the model itself is just different weights of the neural network. You can't use that to generate anything. You need some way to get images out of it. So you've got the Hugging Face diffusers library, which is the code option where you could go to Jupyter Notebook, write some automation scripts, and use code to generate images. You've got Automatic 1111, which is a web UI to generate pictures, and there's another one called ComfyUI. So I've got screenshots of this so you can know which one's best for your use case. And then you're going to have to create a workflow. You're going to have to set a few of these parameters. You generate an image. You'll find that most of the time it's not too great. you find something's bad, or you need to try different parameters, and it's a very iterative process. So by this point, you see that there's a lot more work that happens when you're hosting the model yourself, because you're in full control, but then you're also responsible for setting it on the right path. So bear in mind that working with some of these models does take a bit more effort. You're also going to have to use an upscaler model, because all these images are about 512, 512, or 1024 by 1024. So you've got different models to really bring it up, blow it up if you want to use it for print. So if I had to put an analogy for using Midjourney versus Stable Diffusion, I'd say it's like Uber versus driving your own car. Uber's great at getting you from point to point, but you have no control over the process. Or you have limited control. You can tell the driver where to turn if you want to, but it's not really designed to be used that way. And you're also paying a premium for the service as opposed to driving yourself. So look at your situation and then decide which path works for you. So let's look at some code. If you want to use Stable Diffusion with the Hugging Face diffusers library, it's fairly simple to do a Hello World project. You just have to import the Stable Diffusion pipeline from the diffusers library. You would create a pipe and pick your model. In this case, I think the code's using Stable Diffusion 1.4. If you have a GPU, you'd use a pipe to send it to your GPU. If not, you'd send it to your CPU. Add a prompt. In this case, it's a photograph of an astronaut riding a horse. So that picture probably doesn't exist. It has to be generated from scratch. And then you print your image out, and you get that. So Hello World, really simple. You can build advanced code with different parameters, add some of the other elements, but if you're looking at a quick way to start, that's all that it takes. A lot of people don't like using code to generate images. They want the process to be a bit more iterative, and that's where they kind of go down the path of the web UI. And Automatic 1111 sort of solves that problem. So it's gives you this UI where you can put in your prompt, you can set your parameters, generate the image, view a thumbnail, and then do other things like in-painting or train LoRa. So it does a lot of things, but that's the UI. So what works is it's completely open source, so you can download the code from GitHub. You don't have to pay for this. It follows a no-code approach, so for those that want that, this is where I'd recommend you start. It lets you access all the controls and parameters. So you see, unlike Midjourney, you have a lot more buttons that you need to set. There are good defaults to start with, but for the best quality, you need to play around with this a bit. You also get the live preview, so as the image is generated from noise, you can see step-by-step what that looks like. It supports most of the popular workflows out there today, so it's a good starting point. You can use control nets and LoRa's, and we'll be talking about that. And there's great community support and adoption, so a lot of people are using it. It is one of the more popular tools. The only catch has been the fact that it's really similar to Stability AI's new offering. So they have a Swarm UI that's been in development. It's today in alpha. So I would expect that the creators of Stable Diffusion might build a better UI for their model, but it's speculation at this point, so just be mindful of that. The next option is ComfyUI, and that's the one that I'll be talking about today. It gives you a node-based UI, so you sort of have different boxes for different things, and you drag and drop and connect them. So it's very intuitive for people who are designers who come from background of working with tools like Blender, because it follows the same approach. And it's a bit more flexible than Automatic 1111. So if you want to stop the process halfway, look at the picture, edit something out, and then continue the process, you can do that here. You have a lot of custom nodes, so anyone can create a custom node. It's just a Python script. Works very similar to Airflow, so if you've written Airflow operators, this is just the image version of that. You can extend the class, get what you need. And the best part is, anytime you generate an image using ComfyUI, the source code or the metadata that generates this workflow is also embedded in the picture. So if I generate a picture and then send that picture to you, you just drag and drop it into ComfyUI, and you get all the boxes with all the values that I've used, so you can extend it yourself, play around. So it made it really easy to learn and share from others. The only downside is that it becomes a bit of a spaghetti mess. So a lot of people don't like all the nodes and buttons. Some people find it confusing because you have boxes for the prompts, you've got different boxes for the settings. It does get a bit messy. So here's one that I found online that's quite popular. So you can build massive workflows that do different things just to generate a picture. So it can get hard if you don't control it the right way. So now that we've seen both these approaches, I'll show you how we can control some of the things in Stable Diffusion. So like I said, you have full control, and there's a lot of math involved, unfortunately, and I'll try and gloss over it as quickly as I can, but I do have disclaimers for the parts in case you want to quickly grab a drink or head to the restroom. So here's two of the boxes that I primarily use for generating pictures. So on the left, you've got model details, so it lets you pick the actual model that you downloaded from the internet. You've got prompts, so there's a positive prompt and a negative, where the positive is what you're trying to generate, and negative is things you want to avoid. So the prompt here is a street in Sydney, warm golden glow of the sunset, and I didn't want to see taxis, so I've got taxis in the negative prompt. You also specify the image resolution, so any images that get generated start at that resolution, and you can upscale it later if you want. You've got a seed so that you can control the randomness of the model, and then how many steps you want to run the algorithm for, how much guidance you want to give to the model, and then how the sampler and scheduler are used. And the first time I encountered all of these things, I said, that's too hard. Like, there's no way I'm going to figure out how to use these things. Luckily, experimentation works quite well when you're being creative with pictures. So you have things like XY grids where you can just say, hey, vary my steps from 5 to 45, cursor free guidance vary from 1 to 16, and see which one gives you the best picture. So you can have a very experimental workflow where you sort of play around with things. That's a prompt that I've used. Those are the parameters, so you can see what's fixed and the ones indicated in yellow change. So you can change any parameter. You can try changing the steps versus the scheduler. So some schedulers are called converging scheduler, meaning you could keep going for an infinite number of steps. The picture kind of stays the same. So some of them are diverging, which means after step 40, it's just going to try and generate another picture. So you need to stop at some point. There's a lot of math involved in how these things work, but I think you can be pretty experimental with your approach and find the settings that work. In most cases, models will give you a good range of default that works, so stick to those. You can also try different generations of models. So in this case, I've used two Stable Diffusion 1.5 models on the top, and the ones below are Stable Diffusion XL. So you can see how 1.5 is a bit more cartoony, whereas the XL ones are a bit more photorealistic. So the larger images are getting better and better at generating things. Now, control nets are my favorite part of Stable Diffusion because it lets you control the image generation process. Midjourney doesn't support it, so this is a big plus for Stable Diffusion. And essentially, control nets are other machine learning models that can guide Stable Diffusion. So it needs to be trained separately, and you can find a whole bunch of these on the internet. So there are models that are trained at understanding how to generate images from scribbles. So you could try scribbling something yourself using this control net, and then it would generate the appropriate picture. Same with depth map. A depth map, objects in white are closer to the viewer, objects in black are further away. So it's sort of a 2D representation of the 3D space. You've got open pose models where different parts indicate different limbs, positions of the eyes. So you can get, if you can generate a pose, you can have a character that looks at a specific angle, so you can change the hand, and that lets you do some pretty creative things. You've got normal maps that also let you show how light interacts with an object. So if you want to have very specific lighting, you could feed that in and then generate what you wanted. You've got segments where you don't care too much about the shapes, but you know that the bits in blue have to be a chair, the bits in green have to be a table, and then the model has to creatively decide which table and which chair it puts in that space. And then edges, which is fairly simple and straightforward. It's probably best to see this with an example to see what that would look like. So here's a situation where we have a prompt. I've got the image on the right and that reference image on the bottom, so you can see how it changes over time. So the first thing we want to do is we want to generate a depth map from this picture. So we use the Midas depth map, which is an algorithm, and then when we pass this image, this is what we get. So we get a depth map where objects in black are further away and objects are white. So think of this as a sort of X-ray that the model's working with. And now this becomes the input to Stable Diffusion. So we're going to feed this depth map and then throw a bunch of prompts and ask Stable Diffusion to fill in the blanks. So let's go with something futuristic first. Let's say we want a cyberpunk city with that depth map. It's going to give you that image. So you can see how the structure remains. There's still 3 different floors, the balconies, the windows, all fairly in the same place, but it's gotten a bit creative with the cars on the bottom because there wasn't any information that told it what to do there. So that's futuristic. Let's swing it the other way. Let's try something ancient. And again, preserves the structure, generates a new image, so it sort of fills in the blanks, and you're guiding the model generation. So you can generate a depth map from any image, and then ask the model to fill it in. I tried one to see what a modern apartment in Sydney looks like, and it came up with this. Looks legit. Like, I mean, I can understand the side, the roofs in the background, the water looks like Sydney. So these models are pretty good at doing things like this. You can also control how strongly the control net influences the model. In all of these cases, we said, the control net strength is about 87%, which is quite high. So the model can't deviate from the control net. But in this next image, I think I've brought it down to 40 something, so it can get a bit creative. And that's a Martian landscape. So you can see that there's some semblance of the shape, but it's gotten creative in places where it had to fit the right things in. The next bit is low rank adaptation. Maybe quick show of hands, has anyone worked with LoRa's? It's been around for a while. Okay, one person. So heavy math, and I won't spend much time here, but think of LoRa's as compressions for a compression algorithm for matrices. So if you've got a matrix that's 100 by 100, that's like 100,000 values that you need to fill in. You can break it down into a matrix multiplication of two smaller ones. And if you add those two things, you have 10,000 values. So that's a 10% compression. You'll still get the same original matrix back with some loss, but it works quite well with a lot of these models. So what you would do is you'd have on the left, you see the traditional flow, which is inputs go into a model, and then you get outputs, which is your picture. But with a LoRa, you'd freeze the model, and then you sort of create two other matrices, which get trained separately. The benefit is that you're training on a much smaller number of parameters, so you're only training 10,000 instead of 100,000, so your training is going to happen 10 times faster, and that's sort of the intuition. But again, if you don't care too much about the math and care about what this does, it helps you fine-tune the model to learn a very specific concept, like characters. So here's an Arnold Schwarzenegger LoRa. So those pictures aren't real. Those are new images that have been generated using a model that's trained to generate his 90s era look. Same with Indiana Jones. So that's not Harrison Ford. That's specifically pictures of Indiana Jones that have been given to a model, and it knows how to generate really good pictures. Because I definitely don't remember seeing Pikachu in any of the Indiana Jones movies.
What's in the bench then?
Yeah. So that's how character LoRa's work, where it's understood a concept really well and can reproduce that quite easily. You can also do style LoRa, so you can have different artistic styles. So you can have a dreamy style or a comic book style. And as an example, here's a base image that I've generated. So it's a photo of a dog on a rooftop. That's just the base model. Try 3 different LoRa's. So you've got a comical style, and a sort of illustration style, and another photorealistic style. So you can see how that sort of influences the images. So coming to the end, wrapping up, how would you get started? So I'd recommend using a fully managed service, because you're going to have to learn some of the concepts like in-painting, LoRa, control net. So go with something available on the internet like Leonardo.ai, Stable Diffusion XL on Bedrock, or Midjourney. Don't try rolling it out yourself on first go. There is a bit of a learning curve. You can try a lot of these community-trained checkpoints like on websites like civic.ai, but watch out, there's a lot of unsuitable content on these websites, so you have to have strong web filters when you're browsing. You can try generating your own images with LoRa, so try that out yourself. There's a lot of YouTube videos and tutorials. If you want to try hosting some of these models yourself, try to use services like Amazon Bedrock or other cloud services to figure out what you need to really run it. And if you have your own PC, you can just generate any number of them. So I've got one at home. That's a spec that I have. Make sure it's an NVIDIA, because NVIDIA support for GenAI models is a lot better. Try to get at least 12 gigs of VRAM. Anything less than that, I've seen some models struggle. Don't make the same mistake that I made. Get a bit more hard disk space, because some of these models are really large, so you want to have the additional disk space. Reading material, if you want to read up some of the stuff yourself. So have a look at the official docs on Stability AI, Leonardo AI, OpenAI, and Midjourney. Hugging Face has a lot of repositories and spaces where you can see how some of this works. Scott Detweiler's YouTube channel was a great way that I found to learn ComfyUI. So he's a QA lead at Stability AI. The Latent Vision YouTube channel also does a lot of videos. It's one of the creators of these custom nodes. Simon Collins is someone that I work with that publishes a lot of tutorials about these things, and Sam. That's a link to his website where he trains blogs and training videos. So, and I think what Sam's got a lot of videos about LoRa's where he took his pictures and tried to generate it in different styles. So yeah, these are some ways you can get started. I think that brings us to the end. So if you want to connect on LinkedIn or if you want access to the slides, join the Data Engineering Meetup Slack. I'll have the link up there. And we pause for Q&A if there's any questions.
Round of applause. Thank you.